You know how it goes. I saw this tutorial by Polygon Pen creating this three-dimensional rope type in Cinema 4D and thought, why not give it a try in Houdini? What I prepared for this in my ancient version of Illustrator, and yes, Manu and some of you will rightfully point out that I should have used Inkscape instead, is this single spline forming the word hello. And it's important that this is one continuous single spline, which I saved out as an Adobe Illustrator file, which I will bring into Houdini using a file node, diving in there and pointing it to the Illustrator file that I created here. Hit accept, and you can see it brought in this weird black and blue geometry. When middle mousing on this, you can see we imported a primitive color attribute. Let's just get rid of that using an attribute delete, deleting all attributes. Points, vertices, primitives, and details. So that's the geometry we brought in there. And by default, Houdini tries to fill this single spline here, which I don't want. So let's open it up using the ends sub, setting the close U to open, bringing in my spline. Next, I also want to scale this so it's uniform size no matter what I bring in here, and also center it using the match size. And in the match size sub, I want to check scale to fit and check uniform scale. So it's now scaled to be 1 unit along its largest axis. Maybe save this in between and let's middle mouse on this, and you can see we have one primitive with 109 points and vertices. Let's just switch on point display, and you can see that those points do not sit on the line. That is because this spline is a NURBS curve. So let's convert this using a convert node, and let's increase its U and V detail to 1, so we get all these points forming that spline, which is now a polygon. Lastly, I want to use a transform and just rotate this along the x-axis by -90 degrees so it lies flat on the x and z plane, pointing up along the y-axis. Next, let's resample this uniformly, because now you can see we have a bigger, higher point density in those areas and a lower point density in those areas where my spline is straight. So resample goes in here. Let's set the length to 0.03, I think was a good value in my previous attempts at building this. And I just want to drag this down and check curve U attribute, which creates an attribute on this spline here, on this single polyline, going from 0 at the spline's first point to 1 at the spline's last point. What I'd like to do now is fix those overlaps, for example, in the L's here or in the E or the O here, where the rope clearly overlaps and in reality would bulge up a bit where it crosses the underlying rope. And for that, I'm going to use Vellum and simulate a rope that falls down on a plane, starting with the rope's first point, ending with the rope's last point. And to set this up, what I want to do is move up these ropes, individual points, depending on where they are in the rope. Let me explain what I mean by that. I'm going to drop down a point wrangle, and for each of those points, I want to take this current point's Y position. I want to set it to the curve U attribute we created in the resample node. Now you can see we are getting this here, where this spline or this rope has been stretched along Y. And I'm doing that just to resolve those initial collisions, those crossing points in the L's, for example. So now I'm going to take this and use a Vellum hair constraint. I want to check visualize thickness. So if I zoom in, you can now see those blue circles here, or those blue spheres, showing me which thickness Vellum is trying to simulate this hair at. Let's increase this by increasing the edge length scale. I found an edge length scale of 0.9. Worked well for me. Keep in mind now that you drive the overall thickness of your rope using this resample node's resample length. So a lower point count with a longer resample length also results in a thicker rope. I'll leave this at 0.03. Next, let's drop down a Vellum solver, and in here, I want to lower my constraint iterations a bit, don't need them as high. And if you're intrigued into what these settings do and also want to see more Vellum setups, you might want to consider having a look at our Patreon and our premium contents on entagma.com, where amongst many other courses, we have a Vellum 101 course. Also, I want to check the ground position here, enabling a ground plane onto which this thing can fall. And just for fun, I could toggle real time, save this, and just simulate this. And I'd get this, which isn't bad, and which would absolutely work. So having this rope lying here with those bulges where the rope is intersecting or overlapping. However, I want to set this up a tiny bit different. So what I want to do is disable the gravity, setting this to 0. And now if I hit play, nothing moves except this point down here, which collides with the ground plane and then just sends this whole simulation wiggling. Let's disable the wind and enable velocity damping, setting it to 1, which means after each simulation step, each point's velocity here is reset to 0. So now you can see this wiggly behavior is damped. However, my spline here is not moving. And instead of letting gravity do the work and maybe risking this rope sliding all over the place, I want to use my resampled original version of this. So let's add a null to this, call this null maybe target. And within my Vellum solver here, for each of those points, I want to create a velocity that drags this point to the same point's undistorted position here in the target. Let's set this up by going into the Vellum solver and in here dropping down a pop wrangle, which is running over those points of the simulation. In my inputs, I want to bind to input 4 a sob which I'll point to the target null I just created. So now here in the code in Vex, I can access the data coming in through the null here, through this target null, by referencing input 4, which is the input with the ID number 3. So I want to read out the original point position coming in through the target here. Let's do that by creating a vector, calling it TGT for target, and it should be equal to the point data coming in through our 4th input slot with the ID 3. We want to look up the point's positional data at the same point number as our simulated point here, because they didn't change. And now let's create a velocity, which will directly store onto our simulated point by, from our target, just subtracting the current point's position. And that's all there is to it. So let's again save this, reset it, and hit play. And now you can see this is slowly setting into this rest position, meanwhile keeping those overlapping points apart. One more thing I'd like to tweak in my simulation, let's just reset this to frame 1, is in the Vellum hair constraint. Let's drag this down, and under the bend constraint here, I want to set my stiffness to 0.0001 like this. So that gives me a bit more bendiness within that hair there, resulting in a slightly more natural behavior of my rope. So now my simulated rope looks like this. Okay, now we have this single strand here, which doesn't overlap, but which clearly is not a rope yet. And to generate a rope / woolen thread, or whatever you want to call it, I want to twist a few strands and then again twist those twists, forming my final rope. And I decided on my rope to consist out of 6 strands, and each of those strands in turn consists out of 6 substrands, so to say. So let's start creating this, dropping down a line, straight line, and to it attaching a copy and transform node. So in my line, I want to set this up to contain quite a few points, because this in the end will be the number of points that the center of my rope will have. And as this is quite a lengthy spline, let's go for, say, 1024 points. I want to set this direction to be 1 along the z-axis and set its length to be 4.4. This is a length that I eyeballed and that kind of fit with the length of this spline here. I, of course, could have used a measure node measuring the length of this spline here and then wire this length into this slider here. In this case, I opted to do it manually. Let's highlight the copy node here, and I want to set its total number to be 6. I want to rotate each copy 60 degrees around the z-axis, resulting in not much to see, honestly, apart from this seemingly single line. However, if we offset that single line along the y-axis, you can now see we created these 6 copies. So how far should I offset these individual lines here? Clearly, that depends on our rope's thickness in the end, and the rope thickness is driven by this resample node here. So let's just take this parameter here and copy it, and in our line node here, let's paste it here under the y origin. So paste as relative reference, which in this case is a bit too much. So instead what I want to do is multiply this by 0.33, giving us this bunch of 6 lines. And also in the copy node, I want to translate each of those lines, let's just uncheck point display, a tiny bit, let's say 0.025. So we're getting this kind of stepped beginning here. Next, what I want to do is use these 6 lines and around them twist and sweep a bunch of circles to form those 6 individual strands out of which our rope consists. So let's create a circle first. Let's set it to be a polygon, division of, say, 16, so 16 points here. And I'd like to offset this a bit to the top 1.8 units, because now what I want to do is, again, using a copy and transform node, setting its total number to 6 and the rotation to be 60 degrees around the z-axis, is again create such a flower or cross-section of a yarn using those circles. And by driving this circle's offset, you can drive how closely those circles are packed and touching each other. Now, if I put this into a sweep node to sweep it along this line here, you can see that the scales clearly do not match. So below this, let's just use a transform node and set its uniform scale to something really small. And again, here, I want to use the resample length here, driving the overall thickness of our rope. So again, let's just copy this parameter, and down here in the transform under uniform scale, let's just paste a relative reference. In this case, multiplying this value times 0.075. Again, number which I found out in preparation by a bit of trial and error. Finally, I think I'm ready to wire in those 2 components, so my substrand cross-section and my wires here, my lines, into a sweep node. So the backbone, which is these 6 lines, goes into the left, and the cross-section, those circles, goes into the right slot here. And let's highlight the sweep. You can see we extruded those straight individual substrands here. So let's set up that sweep to form something more akin to a rope. First thing I want to do is reverse the cross section so the normals are pointing outside, and let's drag this down. I don't want to have stretching around the turns, but I want to have a single polygon as an end cap, so now those yarns are closed. And then under the rotation, I want to add a few full twists, so those individual yarns, they twist. So let's try. And I think a value of 90 full twists is looking nice. So the final thing for now is I want to apply the scale along curve here and add 2 points at the ends, which are really close to the absolute end, and then take the endpoint scale and just move this down to, 0.3 at both ends, so those yarns taper out a bit here. Let's move those closer to the end, maybe like so. And let's just go to the other end and do the same thing by positioning that point here closer to the end, like so maybe. Okay, so this is my core rope, which is straight and not winding around any typography yet. First, let's fix the very straight appearance of that rope by adding a twist deformer. And on the twist deformer, let's just scroll down to capture and click set capture region once. And also let's adjust the capture length to the length of our line here, which is 4.4 units. So let's copy this parameter, go down to our twist and paste that as the capture length. So paste a relative reference and add a good bit of twist here. So 180 degrees is clearly too little. And also I want this thing to go into the other direction. And let's really crank this up to say minus 10,800 degrees, like so. And now you can see we have this twisting rope here. However, when we look at this rope's end, you can see the twisting stops shortly before the end. So clearly this capture length is not capturing the whole of this rope. That's because we offset our individual strands here a tiny bit by this value. So in this case, either I could multiply this value times 6 and add it to this value here, or be cheap and just multiply this by 1.05, scaling it up a bit, like so. Okay, now I have this twisted rope consisting out of sub-twisted yarns. Let's deform it onto our simulated spline. And for that, I'll go back to my Vellum setup, which I set up next to my rope here. And for my Vellum setup, first I want to subdivide and smooth this out a bit using a Vellum post-process node, setting its spatial blur to, 0.5, and these subdivisions to Catmull Clark with a subdivision depth of 2 maybe, like so. So a bit smoother now, a bit more points to work with. Also, when middle mousing on this, you can see we are still dragging around lots and lots of attributes used in the simulation, and some of those tend to mess up our path deform, which we're going to use next. So let's drop down an attribute delete and delete all attributes except the points position just by deleting everything. And now let's use a path deform with our rope going into the left and our Vellum sim going into the right input slot, and let's highlight it. And after a bit of thinking and disabling our point display, you can see we wrapped our rope around this Vellum sim. For good measure, let's add a normal node, creating normals on this mesh here, and a UV quick shade to check what's up with our UVs, which we're going to use in shading now. And you can see these UVs are messed up, just a flat planar projection. To fix this, let's head to our sweep node here, where we build the rope. And on the UVs and attributes tab, let's check compute UVs. Immediately you see we're not seeing the grid again, but if we zoom in quite drastically and hitting D, going to view and adjusting our near and far clip planes, you can see we have very tiny UVs that now look correct on those individual strands. Right, back to the end of our setup here where we added the UV quick shade. Let's down here to the normal attach a null, which we're going to call out_rope. Highlight this. Let's talk about adding detail and shading. Usually when you look at images of ropes, they have these stray hairs and fuzz around them. And when building ropes and woolen strands for clients, I found 2 techniques to simulate this very useful. Let's start off with the very obvious one by going up 1 level and dropping down another geonode, which we're going to call, hairs, fur, call it hairs, and dive in there and use an object merge to merge in from our rope rope geometry. And for now, I'm going to make sure that I up here check only hide other objects. So now I'm only seeing what's inside this node here, the hairs node that I'm working on. So I imported my geometry that I created, and to create hairs, I just want to copy a few distorted lines onto this geometry. I'm going to do that by using the scatter align node, which I wire in past the object merge, just dragging this down here. I want to set it up to use a number of points, and down here in the point generation mode, I'll just set the relax iterations to maybe 1. More points, more hairs, less points, less hairs. Also the total number of points depends on the length of your spline. I went with quite a high number, which is 300,000. And then down here on the attributes, I unchecked the creation of a p-scale attribute. I want to create that manually in a second. And on the orientation tab, let's just drag this down again. As we have incoming normals here, we can use that to rotate the individual hairs, which we're going to copy onto those points, to randomly rotate them around the normal between 0 and 720 degrees. And also, I want to have a bit randomness in the direction that those hairs are pointing, so they're not pointing straight up from the surface, but maybe about 70 degrees of randomness. And I will show you the effect of those settings in a second. But first, I want to create a random p-scale attribute using the attrib randomize node, setting it to generate a p-scale attribute, which is of dimension 1. It's a single float value, and I want to drive the distribution with a custom ramp. Let's drag this down, and this ramp drives the distribution of the p-scale values across all those randomly generated values. What I like to do here is set these curve points to be all B-spline, just like so. So every single point is a B-spline. And I want to add 2 more points, setting the first point to have a value of 0.5, second point also a value of 0.5, third point also 0.5, fourth point, again, value of 0.5. However, the position I want to set at 0.95, so very close to the end. And I think we don't need this point here, one too many. And the last point, I want to set its value to be 1.5. So this will generate a few long hairs. All right, that should be it. Let's save this and drop down a copy points node, making sure that I check pack an instance and wiring in those points into the right slot. So what are we going to copy onto those points? Well, a single line with around, 16 points, or make it 24, which is really short, 0.07. Again, trying to adjust to this rope's scale here, which is only 1 unit across the x-axis. So we have to make our hairs really, really small. Let's just highlight this one, centering it by pressing space and H. And to this, let's add a point jitter, and I'll just reduce its scale here to something very, very tiny. So we are getting this offset kinked hairline here. However, that's a bit too harsh here. So let's, to this point jitter, add an attribute blur, making sure I uncheck pin border points, and I blur out the position, the P, resulting in this slightly curled hair. Let's set the point jitter a bit lower, 0.005, like so. Right, and that is what I'm going to copy onto those points that I created. So if I frame this, you can see this is quite big, and I might have messed up the scale of the hairs here, so let me just check. And of course, when comparing this to my original setup in the line length, I missed an additional 0, and now we have this hairs. Let's to this attach a null, call this one out_hairs, save this, and again go up 1 level. And in between those hairs and this perfectly flat rope, let's call this rope by the way and not leave it as Geo1. And of course, one downside of Houdini, as soon as I rename a node on the OBJ level, I have to resimulate. So let's reset and resim. So here we are. So between this rope and these hairs, I want to add secondary detail, simulating this fine layer of fluff that's usually on wool or softer thread. So let's add another geo node, call this one, Fluff, dive in there, and OBJ merge that out rope geometry, which we created in our first geonode here. So to create this fluff, I want to create a copy of this original rope geometry here, slightly distorted, and then add some semi-transparent material to it, just giving the impression of a bit of fluff. There's an easy way to do this in Houdini. Let's just peek this geometry a tiny bit. So let's lift it off from its original geometry a bit. You can see what that does here. So it's expanding this geometry a tiny bit. A value of 0.001 is sufficient. So only lift this one slightly. And then let's use a simple mountain saw to distort this geometry. You can see this is way too big, and also the noise is way too large. So let's dial back the element size to 0.001, making our noise more high frequent. And also let's dial back the height to 0.01. So now if I can zoom in, you can see that this is after the mountain and this is before. So we just slightly distorted and offset our initial geometry here. All right, I think we're ready for setting up rendering and shading this. As with most of our free tutorials recently, I'm going to use Octane here. So let's just close down these 3 tabs, pin this tab here, hit Control T 3 times, and set one tab to the out, the other one to the shop, and the final one to the material network. So if I have Octane installed, I'm going to go to the Octane tab up here, hit render target and Octane, creating in my shop network. If I center this, the render target where I set up the rendering, and in my out context, an output node where I can set up the file path and frame range of my rendering. So let's go to the shop net here, to the render target, set this to be path tracing, and use a texture as an environment. So in the environment texture here, I'm going to set the gamma to be 1 and point this to a texture which I downloaded from HDR Haven. And I use the artist workshop here. Also, let's add a camera by framing our viewport to our liking and then going to the camera symbol and clicking it while holding it down Control, creating a camera at our current viewport, which clearly did not work. So let's see what went wrong here. Just a refresh issue, I think. Let's just properly center this by setting its translations to 1 along X and Z axis and maybe 1.8 along Y. Also, by rotating this straight ahead, like so. We centered it. All right, let's do this. Add a grid as a floor or background. Call this one BG. Maybe scale it down a bit, 0.5. And I mean, we could hit render already. However, that's gonna result in some funky behavior. Everything purple, nothing much to see here. So let's fix those issues step by step. Let's just stop this here. And let's first create a few materials. Call one BG for background, dive in there. And I just want to give this a diffuse material, which I'll wire into the material out here and just give it some dark gray texture here, and then drag this onto our background. And maybe in our OBJ context here, let's disable hairs and the fluff and work on our rope shading first. So let's restart the IPR. And firstly, I'd like to dial in the light intensity in our shop net here. And in the final setup, I increased this to a power of 6, making this very bright here. So I have to counteract this by, in my background material, dialing this a good bit darker, maybe like so. And then let's create another material. Let's call this one rope, which is our main rope material. So you could either drag this onto this rope here or just link it up in the OBJ context under the ropes render tab here. Back to the material. Let's just refresh this IPR here. Still bright pink, because in the rope itself, we do not have a material setup. So I think I used a diffuse material here too, like this. And what I did for the diffuse as well as for the bump is use a noise to simulate those substrands, those fine fibers that form the individual yarn. So I'm gonna drop down a noise, procedural noise, which I'll wire into the diffuse slot here. Not much to see yet because I haven't given it any projection yet. So let's use a UV projection, which I'll wire in here, and a transform 3D. To adjust this noise scale. In the procedural noise itself, I want to set the noise type to be chips. And now you can see we're getting something here. Let's just go to our OBJ level onto the camera, and under the U tab, let's dial in a larger focal length, zooming in a bit. And also you can see now the autofocus is getting a bit wonky. So under the sampling tab, let's just increase the f-stop to something really large so everything is in focus. You can now see we are getting this noise pattern here on the rope. So let's dial this in using the transform node here, dialing back its X scale and increasing its Y scale. And now you can see we're getting the appearance of those individual fibers here. I'll just take this same noise and wire it into the bump as well. Maybe in between adding a texture multiplier to dial in the strength of that bump here. So if I feel tempted to decrease or increase that, I can do that in here. Let's leave it at 2. Okay, so much for the ropes texture. Let's just save this. One last thing I could do is add a gradient ramp, wire in that noise in the input, and then that into the diffuse, so I can drive in the color of those individual fibers here. If I want to recolor them, I could quickly do that this way. Let's just leave the dark one set at something like this. And also let's decrease the bright one a bit to a light gray. Next, let's take care of that fluff. Again, save this and enable the fluff. Maybe take a snapshot of this. And my IPR here is a bit messed up because I have OCIO installed. So I'm going to set this to raw. Okay, let's minimize this and reload this. So this time our fluff should load up, coming through as this pink mess here. Let's create another material for the fluff. Call this one fluff. Dive in there, and again add a diffuse material. Wire this to the output, and just on the fluff node here in the OBJ context, under the render tab, assign that material like so. Okay, really bright material. So let's dial this in the material itself here. And I'll be cheap and just go to my rope material and borrow all this here. Just copy it and go back into the fluff and paste it here. So my procedural noise, I'll just take this gradient straight into the diffuse. So we can now see it's more akin to what we have in the rope, but also I'll just copy these two nodes, the procedural noise and the transform, and paste it down here, giving me another noise, which I can individually scale here using this transform 3D. And also I will add another gradient ramp to color correct this noise's output here, like so, and wire this into my material's opacity. So now you can see that this noise is driving the opacity of that fluff layer that I created. And I don't want this to be so opaque, so let's just take this white here and dial it back a good bit, maybe like that. And now you can see this black stuff appearing here. And some of you might want that and you can leave it in, but what it is, it's a rendering artifact resulting from a ray offset that is dialed in too small. If you want to know what a ray offset is, we covered that, I think, in a tutorial in our rendering premium course. In Octane, you can just adjust this by heading into your render target, which is in the shopnet, and on the path tracing kernel, just decrease the ray epsilon by a factor of 10 or maybe 100, but a factor of 10 seems to have fixed it here. Okay, in the fluff material, one more thing I want to do is add this bump here and also create another color. Let's use an RGB color here, which I'll wire into the transmission here. So we are simulating faking a bit of subsurface scattering with that. In this case, I'll leave this transmission color at its default value. A light gray seems to work nicely, and maybe I'll fiddle around with the opacity here, making it a bit more opaque, setting the maximum value to 0.5. Let's drag this over and maybe just, again, take a snapshot of this. The last thing I want to do is create a material for our hair. So let's create another Octane material builder, call this one hair, and dive in there. Again, going to use a diffuse material, which I'll wire up here. I'm going to use an RGB color to drive the transmission, the fake subsurface. Let's just leave it as is and go back to our OBJ level. And before we enable the hairs, let's just assign this material to it, like so. And then on the Octane tab, let's go to fur and check render as curves and fur, dialing in our root and tip thickness. And with a bit of trial and error in preparation, I found out that these values seem to do the job nicely. All right, let's save this and enable the hairs. Let's reload the IPR, which now is taking a while because we're loading lots and lots of hairs here, and clearly we have some tweaking to do in the material. So let's go back to the hair material and dial back the diffuse value as well as the transmission, maybe value of 0.25 for the transmission, and let's maybe also dial in the diffuse to 0.25. And now this hair is starting to integrate. All right, let's snapshot this too and go back to our OBJ level, close this color selector, and in the camera, under the view tab, let's reset the focal length to be 50 millimeters, resulting in a full view of our now very fuzzy rope. Again, let's just compare this thing by snapshotting the full version, but also just disabling the hairs, reloading this, snapshotting the rope and fluff version here. And finally, let's also disable the fluff, refresh this, and snapshot the rope only version. So let's stop this, open up Mplay where we saved all those versions, and here we can now compare the pure rope with the fluffed up rope with the rope with hairs. So 2 stages of adding detail to this. And that's creating and shading rope in Houdini. All that's left to do for me now is tweak the camera settings, the lighting settings, and just render this out as a final rendering. I personally hope you find this technique useful. I think it's widely adaptable, so play around not only with the spline that you feed into the setup to generate your rope type or whatever you want to form with it, but also with the settings, so how many yarns will form a rope, how twisted is that, etc., etc. And if you want to learn more about Vellum, about rendering, about particles, and about Vex, and also about Unreal, or you just plainly want to support us, then you might want to consider heading over to our Patreon. And to everyone already supporting us, thanks so much, folks. It is your contribution that makes Syntagma possible. And a very special thank you goes out to Rodeo Effects, Important Looking Pirates, Sean Edwards, Chris Hebert, and Refeka Nadol. Thanks so much, guys. And as always, until next time, it is cheers and goodbye.